In the previous two videos, we looked at sine of x. We looked at sine of x, and we also looked at sine of 2x. And there are two ways to visualize this. Sine of x will look something like this. Now, sine of 2x, you can one way to imagine this is to imagine as things being squeezed inwards like this, or another way of looking at sine of 2x is that here it's doing one cycle. The normal sine of x is doing one cycle. Sine of 2x would have done two cycles, one cycle here and one cycle here. And yes, so there are two ways of visualizing what's going on here. And also you can use the same argument for cosine of x as well, rather than just sine of x. So you can use the same argument for cosine of x. Okay. Now in this video we're going to look at well, here we're going to look at sine of x, sorry, cosine of x, and what happens when you have two cosine of x. Okay, so we are going to look at this and see how this relates to this. Okay, so let's have, so this red line here is our standard cos of x here. Okay, the red line here. So you can imagine this as being a point moving around the circumference of this circle here. A circumference. This circle having a radius of 1. Okay, so if you ever forget the difference between cosine and sine, well, remember if you have a point here, sine is the height of this thing here, and cos is the width of this thing here. Okay, so when is at 0 here, the width here is 1. So when the angle is at 0, the width here is 1. So cosine here is 1. Okay, and when it's at 90 degrees, the width here is 0. So it's here. Remember, we are looking at the red line because we are just talking about cosine of x. Okay, so when it's at 180, the width here is -1. 180 here, the width is -1. And when it's at 270, the width here is 0. 270, hang on, 270 here is at 0, and 360 cosine here would be +1. So 360 it would be +1. Now sine, now sine. Remember when you have f of x equals sine of f of x equals cosine of x, which is cos of x here. Remember from our knowledge of well, if we have two f of x here, remember from our knowledge of transformation, if you have a function, whatever function, let's say this function here is f of x. If you have two f of x here, everything will get stretched in well, everything here will get stretched. Remember this from our section on transformation here. So my point is that this red line here is a function, and the function here is cosine of x. Okay. Now the blue line here is 2 cos x. So this is our old function. Now when you have 2 in front of it, it's like me giving you this here, 2 f of x here. And from our section on transformation here, everything gets stretched in this direction here. Okay, and things on the negative side is going to get stretched as well. So this point here will get stretched downwards, and everything gets stretched downwards as well. So looking at this is cosine of x is 1. Well, so this is the red line is f of x. Okay, now the blue line is 2 f of x here. So whatever the f of x was, you've got to times it by 2. So it was 1. Now times it by 2. So it's here now. Now when it's at 90, when x is 90, the f of x is 0. You can see it. You can see f of x is 0. Now looking at 2 f of x, Well, f of x is 0. 0 times 2 is still 0. That's why this point here stays where it is. Now, looking at this here, f of x here is negative 1. So f of x here is negative 1. Now, looking at 2f of x, well, looking at 2f of x, well, f of x here is negative 1. Now, negative 1 times 2 will be negative 2. So again, it gets stretched outwards. It gets stretched downwards. 270, f of x will be 0. Now, looking at 2f of x, well, f of x is 0, so this box here is 0 times 2 is 2 times 0 is 0. So that's why it stays at 0 here. Now, looking at 360, so 360 here, 360 cos of 360 would be 1, because remember, cos is really the width of this thing here. So the width is 1. Well, 1 and then you times 2. Well, sorry, f of x here is 1. Okay, here, and now you wanting to look at you wanting to look at 2f of x. That, well, this here is 1. What's in here is 1 times 2. That's why this point here gets multiplied by 2. Okay, and one way to understand what's going on here is, well, remember the red line here is cos of x, meaning the width. Cos, remember, cos is the width here. So as this thing moves around, you're looking at the width. Okay, so cos of x looks like this. Now, to understand 2 cos of x here, one way of doing it, one way of trying to understand this here is to look at this. Here you've got, here you've got a circle of radius 1. Okay, so here you've got a circle of radius 1. Here you've got a circle of radius 2. So here, when the angle is 0, you can see that from here to here is 2. So when the angle is 0, the cos of this big circle here is at 2. Okay, when it's at 90, is at 0. When is at 180, which is here, this is negative 2. So that's why this blue line here is at negative 2. Okay, and 270, it would be, the width here would be 0. That's why it's at 0. And back to 360 here, the width here would be back at 2. Yeah. So one way of trying to understand 2f of x here. So f of x here, you can imagine this as being a circle of radius 1. 2f of x would mean a circle of radius 2. So this is just another way of us trying to understand 2 cos of x. Okay, it's to imagine a circle of radius 2. It's just a way for us to try and understand this thing here. We're using these circles here. It's just a way for us to try and understand 2 cos of x. Okay.